Okay, so I got through that last video and realized that I gave those definitions and then didn't do an example. So I'm going to go ahead and do an example real quick for the even and odd functions. Just one example. So for even functions, the rule of, doubling the integral, that's just helpful for computation. I'm going to show you an integral that we wouldn't be able to do without, that fact there. And if you're interested in the derivation, check out the book. It should have been done for you last semester. I'm not going to do it here. I might start doing, I'll probably stop. I will start doing that for the sections that are new to us. But so for example, we have the integral from negative pi over 3 to pi over 3, x to the fourth sine of x dx. And so one thing that should tip you off is that, the bounds on my integral, negative pi over 3 and pi over 3, those are symmetric bounds. So I'm going to be able to use some sort of symmetry here in all likelihood. So my function here is f of x, x to the fourth sine of x. And I'm going to figure out if it's even or odd. So I'm going to look at f of negative x. So when I plug in negative x, I get negative x to the fourth sine of negative x. So negative x to an even power gets rid of the minus sign. So anything to an even power is always positive. So this is just x to the fourth. And then the sine of negative x, so you should remember sine of x, or sine is an odd function. So I can pull this minus sign out of the minus, or of the sine of minus x. I'm left with negative sine of x. So this is negative x to the fourth sine of x, which is negative f of x, because this part right here was f of x. So this is an odd function. And that makes this integral actually really easy to evaluate, because this is an odd function, and I'm integrating from negative pi over 3 to pi over 3. This is 0. And you can sit there and try and, figure out how to integrate this. You actually need something that we're going to learn later on in the semester, integration by parts. So right now we don't even have the tools to, if we'd wanted to, evaluate this using antiderivatives. So it's always good to, check symmetry first before you start trying to just find an antiderivative for something. So that'll be the last of that. So I'll move on to the next section now.